Allô, allô, allô.
Est-ce qu'on peut faire un petit test micro comme d'hab? Tu vas te mettre dans un endroit où il n'y a pas trop de bruit et je vais sur YouTube voir si le son est bon. Là, il est allumé, il est pas mute, hein? Ouais, il est nickel. Ok. Je vais essayer là-bas. Super.
Est-ce que d'ici ça va? Est-ce que d'ici ça va ou est-ce que tu me vois? Non, tu ne me vois pas. Est-ce que tu m'entends? Eh oh, eh oh. Est-ce que tu me... Je sais plus ce que c'est les paroles après. J'essaie de faire du bruit avec ma bouche dans le micro, mais je ne sais pas si c'est sur le sujet. Je ne suis pas sûr. Je fais des tests encore, mais c'est pas super concluant. Est-ce que tu m'entends? C'est bon?
Tiens, je pas sur YouTube, mais le son était bon, donc je pense que tout est bon.
Super.
Donc ça, nous, je vais aller poser le fond, je pense, comme d'hab. Et ça, je vais couper les micros en attendant. C'est bleu quand ils sont en dessous. Sur ils sont live. C'est la transition.
Non, t'inquiète. Merci.
Ah, ça va foutre le bordel sur le stream. C'est en mi-présentation. Ouais. Clément, ouais, tu peux ouvrir Keynote. On va le tester sur son ordi. On attend que ça récupère les derniers changements.
C'est bon ça?
Ouais, non, ça, il va pas. Attends, vas-y, on réessaye. Ah, tu as fermé?
On va commencer.
Dans 5 minutes, ouais.
Euh,
airdrop ne marche pas.
No airdrop.
Tu peux retry?
Je peux te l'envoyer par notre
Par mail.
par mail, ouais. Ouais. Valentin par mail sinon. Ok. T'as son mail?
Ouais, 80 mégas ton.
Merde, sérieux?
Par mail, il va. Attends, faut que je le mette sur un drive.
Oui.
Mais je sais pas ce que t'as mis dedans, mais c'est.
Ah, j'ai repris notre presse de Swift Connection et j'ai enlevé des slides et j'en ai mis d'autres, mais j'ai pas fait gaffe au poids. Comme un gros malin, j'ai fait une presse de 80 mégas. Donc,
Ah ouais, merde.
pour 5 slides en plus, tu vois, c'est quand même un peu gênant. Donc j'essaie de te les envoyer
Par mail, ça passe par iPhone normalement.
Ah oui. Ouais, ça ouais. Ok.
Tu vas arriver sur la boîte pro.
Bon, s'il y a pas une petite histoire comme ça au début,
c'est pas drôle.
un meet-up. Hein.
Ah, j'ai pas des fonds.
C'est pas grave, c'est pas grave. On va pas s'emmerder avec de la fonte. C'est super. Bonjour, bonsoir.
Salut. Sorry, in English, I forgot. Hello, everyone, and welcome to the October edition of the Cocoahead Paris meetup. You hear me? Loud? Louder? Louder, okay. So thank you for being here. We haven't met in a while. Last edition of Cocoahead Paris with regular talks like tonight was, I think, in April, so quite a while ago. So it was time to see each of you today, and that's great. First of all, thank you to Amo for having us here in those amazing offices, and obviously the weather is with us tonight, as you have seen. Before starting, few words. First of all, I'm Greg. I was an iOS developer for 10 years. I stopped being a developer 6 years ago to create a recruitment company, but tonight I am here as the co-founder of Tech Connection, which is the company that organizes those meetups as well as other events, and one of those you might have heard. Swift Connection, which was actually 3 weeks ago. Who was there? Quite a lot. Thank you. I hope you enjoyed it as much as we did. It was the biggest edition we did since we started that back in 2016. It was the first time we had Apple on stage, which was huge success and improvement for us. And also we did move to a bigger venue, the Théâtre de Paris, which is a very nice place. You were also 400 of you to this conference, which makes it the biggest iOS conference in Europe, which is pretty cool. Those are final slide and so on. Tickets for next year are already online. We have few, I think there is like 10 tickets left on the Blackbird, which is 33% off. And for those of you who would like to see the talks, the videos will be online on our website in 2 weeks. Those videos will be free. Even if you didn't attend the conference, you will be able to see all the talks. Another topic I would like to talk to you about is Swift 6. So obviously you know that Swift 6 is coming up. It's actually the biggest update of Swift almost ever, since Swift 5 was released 5 years ago. For a language that's 10 years old, that's quite a lot. And why that? Because there is a huge topic coming up with Swift 6, which is concurrency, and there will be a lot of things to do to migrate those things. And you might have seen that. I don't know if you have seen that. This is real. This is not made up. It's a real Apple WWDC video about migrating to Swift 6. So if even Apple is talking about panic when it comes to migrating to Swift 6, it means it will be hard. Maybe like Swift 1 to Swift 2 for those of you who remember that time. So we do those meetups and conferences. We do also trainings, and we have especially one training about concurrency with Swift 5 and 6. Next session will be November 8th. There is only 5 seats left, so don't hurry up if you want to attend this one. We have also our Advanced Swift UI workshop. The December session is full, so the next one will be in January. And those trainings are made by the one and only Johnson Dale. I know there is some fans here. Last thing, are there any iOS leads or mobile head of mobile here? Not that much. Okay, a few ones. We are working on several things at Tech Connections that might be helpful for you as lead developers and also for your teams. So if you want to chat, this is my Calendly actually, so we can see if we can do interesting things together. That's it for this very way too long intro. Once again, thank you, Amo, for hosting us tonight, and I will leave the mic to Guillaume.
Welcome, everyone. Thank you for being here at Amo tonight. So I'm Guillaume. I'm an iOS engineer at Amo. Sorry. Let me tell you a bit about Amo before we move on to the talks. So Amo is a social company. We're building a social network made of multiple applications. If you don't have tried them already, we have already 3 of them on the App Store, maybe more coming in the future, actually. So there is one that we are particularly proud of, which is called Bump. I really encourage you to try it tonight. It's an app where you can see where your friends are in real time, and you can also track where you've been in the past or the past weeks and months, and it adds up over time. So if this is your first time here, go ahead and download it, go through the onboarding, and then try to bump. You do that by opening the app next to someone else, so the person sitting next to you, for example, and then you shake your phone together, and you will see what happens. That being said, we'll have drinks and food here. We have pizza coming later tonight, so don't hesitate to go over there between the talks if you have time. And that's it. Thank you for being here. And I'll leave the mic to Clément and Marty, who are going to do the first talk.
Éteins-le. Allez. Hello everyone. So tonight we are going to talk about Swift macros, how you can harness and maybe abuse them. So my name is Martin. I started iOS development in 2010. I'm starting professionally in 2012. Some of the things I love reverse engineering. Jailbreaking was my intro into iOS. And I'm also liking great UIs.
And my sorry. My name's Clement. So I've been doing iOS since 2010, professionally since 2014. I'm part of the growth team here at Amo. So if you have any issues regarding our onboarding, see me. I'm a huge advocate for engineering quality of life. And yeah, thanks.
Okay, so let's dive right in. So the subject of the talk is how to have an enforceable state-based configuration. Today, there's multiple problems for that. Look at this transition. So this is UI button inheritance chain. We can see that UI button inherits from UI control, that inherits from UI view, that inherits from UI responder, that inherits from any subject. One day, one of your product designer may say, I want my button to be reactive to touch. So what do? You subclass UI button. You create a bouncing button in your app, and it works perfectly. A few months later, the same product designer come to you and say, I want the same behavior on a view. What do? Subclass view. That leads to code reuse. That's not ideal. What will be ideal is to be able to do that. But as we know on Swift, it's not possible to have multiple inheritance, and Tim Cook is not happy about it. Another issue that we may have is when, for example, setting background color on a view. You can do it on the init, you can do it on view did load, but everybody can call it and everybody can modify the background state of your view. That's not ideal if you want to maintain a state that you control. The inspiration from this talk is actually from iOS 15 UI button configuration. So on iOS 15, Apple introduced this few methods. You have a UI button configuration that's optional, and that handles all the internal state of the button. So the text, the background color, the corner radius, stuff like that. And you have this thing, a configuration update handler. So on the right, we can see the configuration update handler. And basically, it will be called every time the button state changes. So for example, when highlighting a button, the state change, the update handler is called. And here, we have the instance of the button. And if the button is highlighted, we change the config based on that. Otherwise, we do the opposite. And we assign the configuration to the button. That's great, but that's only available for buttons, sadly. So how can we make the same behavior, but on any class, like native class or custom classes? First, there's extensions. We can maybe say configure on UI view, that will take a block, that will configure the view, but that's not great because everybody can do it the way they like. We can enforce this configuration by using a protocol, configurable, for example, but that implies that the configuration model will be the same for all the subclasses. So button configuration will use a big model, UI view configuration will use a big model, and you have to cast to the particular models you want to use. So that's not great either. And both of the solutions do not handle the state change. So for example, if I have an UI switch and I want to be able to change the configuration based on the is-on or is-off state, I cannot do that with blocks. So we explored for not that long, a few days, maybe weeks. So this is still a proof of concept. It's not production ready by any means. It's not finished, but it's interesting. And for that, we're using Swift macros. So let's look at the code. We created two new macros. Those are attached macros. The first one is configurable. It takes a type, and whether or not you'd like to animate the changes. And the second one is the configuration model macro that will also take a type and the animation state. Let's have a look at those macros and how to use them. So for the configuration model, we have a protocol, UI configuration model based on configurable model, sorry, that handles the background color property of the view. Below, we have the macro attached to UI view custom configuration, and we are telling the macro that we want to control UI view with it. So this struct is basically implementing the protocol, just above it. What does the macro do? It creates within the type a public protocol configurable. There's 4 functions inside this protocol. The first one is to generate the current configuration based on the state of the view. The second one is to reconfigure the view. The third one is to apply the view configuration, sorry. And the last one is to configure the view using an update block, like the UI button configuration update handler. Now let's look at the configurable macro. So the configurable macro takes as a parameter the model that we used just before, and we are extending UI view using the protocol that the first macro generated. We have to implement two of those functions. The first one is to generate the current state for our view. So we are just mirroring the background color inside the configuration. And the second one is to apply the configuration to the view. We can see we animate, we change the background color animated, and we complete when the transition is finished. What does the macro do? So first, we store an update handler inside our UI extension. I have a question. How to store something inside an extension? Is that possible? Yeah, we are using Objective-C runtime for now. So that's pretty bad, but it works. Then we have the configure UI view. Configure UI view will take the update handler, and we just assign our update handler to our instance of view, and then we can immediately reconfigure view. What does reconfigure do? It generates the current configuration, it checks if the handler exists or not, and if it exists, it executes the handler and then applies the resulting configuration to the view. What does that look like in the code? So here we have a button. We configure the UI button, and we get the configuration and the instance of the button. And then, similar to what we saw with the UI button configuration, we can do basically the same thing. And what's neat about it is like you can configure the UI button, but you can also configure the view within the button, and you can configure drivers. So what are drivers? So remember the example about the bouncing view. We cannot subclass because we are already on the native type. So UI view, using extension and associated objects, can have multiple drivers. They are all cumulative. So for example, in our demo, we have the haptic bouncing driver, the vibrating driver, and the unwheel indicator driver. And those drivers are also configurable. And those driver holds an instance of the view as a weak reference. That's important. What are the limits about this process? First, Swift macros are okay, but they are not the best solution for this. Attached macros are good. Freestanding macros are not that good because it's not as safe, let's say, as attached macros. And as you saw on the first slide, we have a protocol for the model, and then we have a struct. Why that? Because protocols cannot embed nested protocols. So if we want to have namespace protocols, we have to use a struct. That's pretty bad. Then the Objective-C runtime. Clément is not happy about that. Guillaume is not happy about that, but that's okay. Yeah, it's required to store the data handler, basically. Sorry. This solution is not mature enough today to do performance testing or complex cases, for example, animation regarding layout constraints, and like layer properties. And finally, building Swift macro is not that easy. There's two ways of doing it. You can do it the way Swift Co does it. Great presentation, by the way. Swift Cobox. So you have to declare everything using syntax expressions. Can you tell me what this code does? No. And you can use our solution. That's pretty bad, but that works. And that's readable, easily editable. And maybe in the end, when everything is finished, we'll move to a proper declaration. But for now, that's what we have. And now I will give the mic to Clément to show you how it works in real life and without exiting Keynote. Yay.
Yeah, thanks, Marty. So let's go over basically how to.
Sorry.
So let's get let's try to get working a prototype over what Marty just showed us. So we have a view configuration model here, which will expose the different attributes that we'll want to modify for a view. And here down the road, we'll have different drivers. Here, we could see we have the actual implementation of our configuration and attached with the macro. And if we expand it here, we could basically see all the boilerplate that we don't have to write. And this part here, the apply, this pretty much is the underlying logic that will apply the configuration values to our backing view. So that's a quick and simple example for a view. For a button where Apple, the button configuration Apple provides is pretty good for us, but we'd like also to modify the view configuration since button inherits from view. So we could do that here. So let's look at the view demo. So we have a rather simple UI with a view with a modifiable corner radius, some background colors, and some drivers we can play with. So here we have basically value change when the corner radius gets updated. So let's see how we can configure this. And using the generated code, we could call a configure view, which will pass us the current view's configuration. This configuration contains the existing values of the view, and we'll get to apply the new corner radius that we want to pass down the road. Let's do the same for the background color. And so here we could also see the different drivers. So these drivers are, for example, things your designer will want to have some specific behaviors. For example, the haptics. This one will basically attach a tap gesture to your view, which will, based on tap, perform a given behavior. This logic does not have to live within the view itself. It will be defined within the driver, and which will do its own logic. Vibrating will give us a vibrating effect, and the unread will basically give us the badge. So let's run this and see what happens. We get to modify corner radius, not too fancy, but hey, it works. Then here, the background color, we're not modifying the view itself, but the configuration, which will accumulate all the values. And here with haptics, basically on tap, we get a tap gesture, which again does not reside within the view, but within the driver itself. So yeah, let's jump into a button example. And so here again, we have a segmented control with basically 3 different primitive button configurations based on your design, and again some drivers. So here we're going to put, So basically, based on the state of your button, we are going to apply different, for example, images, basically behaviors based on the internal button state, and at the same time modify the logic of the underlying view. So as you can see, we could basically play around with this and not do it at the view level, but at a configuration level. And again, apply our different drivers, which are not specific to a type, but rather abstract, all of that. And yeah, thanks. Back to you, Martin.
Thank you very much. And to remember, this button and the view before are native UI views and native UI buttons. Can you do that with a native UI view? No. So what are the next steps? Where to go from now? First, we want to try to integrate it into our code base, maybe on a new component somewhere like external from what we use today, because we're not pretty sure it will work in the end, but we want to try it. We need to check the performance and also the other solutions to build them, maybe using sorcery, for example. Macros, as I said, are not that great for what we do. Let's automate more. Let's generate the configuration model automatically with macros, and maybe the apply configuration as well, so we don't have to do anything. Everything will be handled inside macros. And last, we need to test with SwiftUI and Swift concurrency. We didn't do that yet. And finally, to sum up, this is only a proof of concept. If you want to do it yourself. It's not that complicated. It works. We can extend we can add way more functionality to this, but we are not sure where to go from now. Thank you all very much. And if you want to work on those kind of problems, go to this URL, amo.co/jobs, and you will find open opportunities. Time for questions.
Some questions. Thank you. You need 2 mics for the question.
Yeah, hi, good evening. Thank you for a great presentation.
Thank you.
I find it really interesting as a concept. I'm just always a little bit skeptical when I see this sort of PR in our code base.
Yes.
And I always have my antennas open for what I call over-engineering.
Yep.
And so, like, this is a genius solution that you've come up with, but as someone that's never done UIKit in her life, once or twice, but nothing serious, my first thought is to go to SwiftUI and to tell you to try this out because it's really awesome for that sort of stuff. And I'm just curious, like, as a general rule of thumb, because I'm very junior, how you balance these complex solutions with like not over-engineering solutions and trying out different things. So you've tried the macro approach. I'm guessing you're going to try SwiftUI, or at least I encourage you to. But yeah, I'm curious how you reason about that, the cost versus benefit. Thank you.
Thank you. So the idea was to replicate UI button configuration, but on any type. That was the base idea of this. I know SwiftUI has states that handles stateful changes automatically, but we are using UIKit mostly here. So we wanted a solution for UIKit. And about the over-engineering, this is a proof of concept. It's not ready at all to go into the code base. So we'll make sure that if we do put it in prod, it will be safer than what you saw, basically. But yeah, we tend to not over-engineer stuff, except when we are doing like tests like this. But after the test is done, if it's a good thing, we'll find a way to integrate it safely into our code base.
Thank you. Another question. No, that's fine. Thank you.
Thank you very much.
Before moving on to our next speaker, we have a few slides changed.
Yep. Alors, il y a juste à brancher ça, normalement. Déconnecter ici. C'est bizarre.
Feel free to talk to your neighbors, introduce yourself, speak about the weather and so on. We have a few technical things to change in the meantime.
oui. C'est pas comment l'écran, mais toujours comme ça. La plage de nuit est là. Et la photo.
Ah oui, pardon, le micro sont là. Désolé pour les gens qui sont en stream. On change les slides et on change de machine et on arrive dans 2 minutes quand tout est prêt.
Là, il est on. Et bah, je pense qu'il commence à partager. Voilà. Et moi, je vais vérifier si c'est nickel. Il y a besoin des 2 micros. Elle est activée ta caméra?
Ouais, ouais.
Moi, je veux dire sur le Meet.
Normalement, oui.
Parce qu'il a fait un truc magique.
Non, je suis là.
Parce qu'il est activé, t'es dans le Google Meet? Ouais, il est là. C'est bon? On n'a pas lié. Ah. Je sais qu'il est là. Moi, je ne vois pas dans le Meet. Ouais, on va la réponse. Je vais vérifier.
C'est bon?
Ça aussi.
J'enlève. J'ai un petit peu de stress.
Super, c'est tout bon. Merci pour votre patience. Sorry. We will start again soon. Thank you. And our next will be about logging. Go ahead.
Hello. Good evening. Thanks for being here tonight, and thanks for Almu for welcoming us. So this talk is going to be about logging in general, but also the OS log framework in particular. It's going to be a little intense, so I'm going to be a bit quick and fast on some slides. So without further ado, let's get started. But just usual stuff. Nice to meet you. My name is Adam. So this is my third Cocoahead talk. I'm currently an iOS and macOS developer at Proton VPN. And also, like another speaker, I used to be like a jailbreak twig developer, and I'm still really into everything reversing related. And also, if you see someone online named Adam and with this avatar, it might be me. It might be me. So logging, what is it? I mean, I think you all know what logging is, but what APIs do we have at our disposal to do logging? So maybe you've encountered this one if you did some C programming, so printf. If you did some Objective-C, you've probably seen NSLog, which is doing the same thing except that it gives a bit more information, such as the timestamp and other process-related informations. Also, it does not print to standard output. We'll see that a bit later. You can use NSLog also in Swift. It's almost the same without the @ sign. There is the famous print that you all know. But there is also one thing that I call the barbarian way, which is like doing the same thing, but using some lower level primitives, such as the write system call. And you give it 3 arguments. So the first one is the file descriptor. So 1 for the standard output. Then the data you want to write to the standard output, and then the size of your data. But obviously nobody does it like that. Probably like some of the functions above do a write call or anything else, but might be possible. So that's it for my talk. I'm joking. So about print, this is the print prototype of the function. So as you can see, it takes a variadic list of items of any type. So you can pretty much, as its name implies, give it anything. So there is a separator which defaults to a space and a terminator which defaults to a line break. So if you're using print, prefer doing like something like this. If you want to print 3 variables, just take the benefit of using the variadic list and give it var1, var2, var3 instead of giving a string and doing some interpolation to print the variables inside the string. And same thing, like if you want to print some text in front of the variable, use the variadic list instead of always interpolating the content. So as I said, benefit from the terminator and the separator. And also, there is a variant of the print function, which is debug print. It has the same signature. The only difference is that it would prefer printing the debug description. So if your object, well, instance of anything, struct or object, is conforming to a custom debug string variable, it will prefer this description. So, okay, that's nice. That's about standard output, but what about the standard error? So there is a variant of print. This one, it's the same prototype, except that it takes an additional parameter, sorry. So the output parameter of type of the generic type target, and there is one constraint on this target generic type, which is to conform to the text output stream protocol, which is a very simple one. It just has one constraint, which is to have a write method. So you give it the string, and then you're expecting the instance to write it somewhere. So in our case, some sample code I just found on Stack Overflow, and I found it pretty nice. So we are leveraging the file handle API from the Foundation framework. We're just grabbing the standard error descriptor or file handle, and then we're making it conform to the text output stream protocol. We're implementing the right requirement, converting the string to a data instance, and then writing to it. And then you can print to the standard error with this. And also this sample code works on Linux, since in Swift 6, the Foundation framework is now available on Linux as well. So I used to think that importing Foundation would not make it work on Linux, but I tested it, and it works in the same way as on macOS. So about the fundamentals, about logging. So it may sound obvious, but it has to be synchronous. Otherwise, it would be really hard to reason. Like, what if you do some operation, you print something, that you do another operation, and the print is done after the second operation? It will be really hard to debug. So it has to be synchronous. It has to write somewhere, but where? Like, as I said, you can write to file descriptor. So again, on Unix system, 1 is the standard output, 2 is the standard error. But also we can write just to regular files. It's possible, maybe if desirable in some case. Also, obviously, it has to be fast. You don't want your program to slow down because you're logging and then it slows down your program. I say that because I worked on an application where in some certain conditions, the app would take like more than 20 or 30 seconds to boot on a very specific condition. So it was a bug, obviously, but yeah, on very old hardware, like an old iPhone or something, the app would take a long time to launch. So logging, it was due to just logging. So it has to be fast. And there are several strategies to achieve that. For example, an API that you might already encounter, which is static string. So basically, static string is just like a regular string with the fact that it is known at compile time, so the content cannot change. And also various optimization at compile time, such as what is doing the OS log framework by doing like a heavy usage of preprocessor macros. So it's not Swift macros, it's macros in Objective-C. Like if you're using the OS log framework in Objective-C, you will see that if you come and click on the log function, it's not a function, it's a macro. And they're leveraging this to insert lots of code in your program to make it run a bit faster than just using a regular print. So string and static strings, so where are they? Where are they stored? So on the binary on macOS, on Apple platforms like iOS, macOS, the format is the Mark-O format. And this format, just quickly, there is a header, then there is segments and sections, and there is a specific segment for a specific use case, which is containing the strings, the literal strings of the binary, and the segment is the underscore text, and the section is underscore C string. You can have the strings by a tool on the command line to inspect those, or also the OTool tool. And at runtime, where are those strings stored? Well, it depends, like on the string size, which is that if the string is a short string, like if it has less than 50 UTF-8 code units, then it's stored on the stack alongside the Swift string struct. So basically, you have your struct definition in the Swift language, and if the string, is a short string, then it's stored on the stack. And it's actually a very known optimization trick that is done in C++ by someone at Facebook. And since the Swift compiler engineers are C++ heavy lovers, they brought it to Swift as well. But if your string is a long one, then otherwise it's stored on the heap. And it has obviously implications like the management of the string with memory allocation and stuff like that. And what about static strings? So you probably, as I said, encountered those via, for example, hashtag line or hashtag file ID, pound, sorry. And so we are stored in the same place as the regular string. And actually, the cool thing about static string is that they're really simple. Like the definition of the string is just basically a pointer to the location in the binary where the string is declared. So it's pretty easy to manage. So actually, I will do a small demo to just show that to you. So I made a very simple tool, like a very, very basic, you will see. With it just creating one string and one static string, and then outputting those. So let's run it. But actually, it's not the output that is interesting to us. It's, as I said, like the binary. So if I do this, so I run it, as you can see, just output some strings. But then if I'm doing like show build folder in Finder, then, okay, Finder is buggy. Products, show build folder in Finder. Okay. And then products, debug, and then there is my binary. So if I'm going to the terminal and running the strings tool, actually, sorry if I put the mic. So I'm running the strings tool with the binary, as you can see, it just found the string that are defined in our product, in our binary. So it's pretty obvious. But as I said, there is also like the section tool, the OTool tool, which can give us lots of information about the binary itself. So if I run it, you have the help of the OTool tool. You have this option, which is -s segment name, section name. So it will just give us the contents of the binary at this particular place. So if I'm running it, so OTool -s. So actually, I just already ran it. So text, and then the path, very long. So as you can see, you have some binary stuff. It's pretty not, we don't have much information, except if you're able to decode it with your head. But actually there are some other tools. So if I can grab the address here, So don't bother about the one here. We don't care. We just copy this. Then I don't know how this is in hexadecimal, so I'm using in decimal. So what is this hexadecimal value in decimal? So I'm going to use Swift to convert it. So it's 16,000, 2,000. Anyway, it says 1208. And then I'm going to copy it. No, don't care. Just remember the value. And then go back to the Finder. I'm going to use some hexadecimal editor tool like xedit. And then if we go into 16208 in the binary itself, where is it? Okay, here, you can find it here. And I can assure you that it is 16208. So anyway, just to give you some knowledge about the fact that those strings are just in the binary and the compiler is able to retrieve those with some magic. So let's go back to the presentation. So now we're going to talk about OS logging. So this is what Apple is calling the structured logging. So it's a bit different to just using print, because print just outputs to the standard output. Structured logging is different. It has some notions about loggers and categories and subsystems. So there is a logger instance. You just need to instantiate one, give it a subsystem string, which is typically your bundle identifier. Then you give it a category, so you can have multiple loggers, like one dedicated to network, one dedicated to storage, anything. Or you can just use one, it's enough sometimes. You have your usual levels to log. And it's, again, OS log is built for performance. So as I said, they are using lots of compile time optimizations, and inserting lots of code at the place where you're doing your log call. And again, also it has some notions of privacy, so it has some APIs to be able to log some string and to hide some. If there is, like, for example, some password that you don't want to be visible, you can just precise some privacy levels. So you just give it an OS log message instance, and then on your logger, you can call this log function. So actually, this is the most basic one, but there are lots of easier log functions, like one called info, debug, error, and stuff. But in the end, they're all calling this one, giving it an OS log message instance. But actually, you don't do it yourself. You're just giving a string literal, and then the compiler will do some magic. And actually, basically, what is done with the static string. It's something similar with additional metadata, obviously about the privacy level and stuff. And yeah, it is the trick that we talk about. So there is, for retrieving the logs, actually it's a bit cumbersome, to say the least, like because there is an API that is called OS Log Store that used to be available first only on macOS, then it has been brought to iOS, but it was buggy, so they removed it, and then they added it back again to iOS 15. So it's called OS Log Store. Then on iOS, just instantiate one like this. So as you can see, there is this scope notion of current process identifier to retrieve the logs to the current process. So there is a hint, like, will this work with extensions? Maybe not. And on macOS, actually, there are lots of more APIs. Like as I said, it used to be first an API for macOS. So you have, like, can retrieve the local OS log store. You can just give it, it's the same thing, giving it the system scope, just like on iOS, you give it the current process. On macOS, you have the system scope, an additional scope, which is the system scope. And then also you can give it like a local URL to some file archive formats that we'll be seeing just right now. So on macOS, on macOS only, there is a command line tool called log, and actually it serves to retrieve the logs of your machine, and you can have lots of options to filter based on your app, on your process ID, on your category, anything. Actually, you need to have root privileges to run it on your Mac, and you can give it an option like last 5 minutes or last 1 hour to just retrieve the logs from this time span. There is lots of other commands in the subcommands in the log commands, just like show, to be able to see the contents in your terminal of an archive. And there is also the log stream. You can just stream the content of the log on your machine using the log stream command, and you can as I said, have lots of filters like to filter by process ID or process name, etc. Also, you can read the manual. There are lots of tools in this tool, lots of options in this tool. So some other facts, like when you run the log tool, it gives you a log archive format, which is pretty opaque. Like if you see the contents, it looks like garbage, but what I want to say is that there is no documentation, public documentation about it. So you just have to trust Apple tools. You can use the console app, or as I said, the log show command, and give it the file. And you can also inspect it programmatically with the OS log store URL API that I showed you earlier. And there is also this notion of profile to be able to disable or enable logs. Quickly, so the signpost API, I don't know if you used it. So this is a cool API by the OS logging framework, which allows you to measure specific parts of your code. So basically, you just create a signpost, and then you're doing like a start, you do your operation, then you do stop, and then using instruments, you can see like how much time did it take to perform this task. So actually, it's a pretty cool tool, and it has a very low overhead. And also it uses the same system as OSLog with the logger. So if you created a logger with a category or it's a system, you can just give it to the signpost, and then you will retrieve it under this category. And also the activities API. So this one is a bit less known. So there is an activities API in the OSLog framework, which allows you to, so this is the activity object. And it allows you to retrace and gather related steps. So what it does is like if you do like lots of logs, it's sometimes a bit hard to follow and say, okay, like you have lots of logs between the logs you're interested in, and an activity can allow you to gather the rated logs that you're interested in. So you create an activity, you log into this activity, and then the activity is destroyed, and every log that has been done under this activity will be gathered by the OSLog framework. And actually, it's not known because it's only an Objective-C. So if you see like documentation, there is no Swift API for it right now. And again, I suspect that it's because it's macro heavy for now. So it's a bit hard, to port macro-based code to Swift, because Swift only recognize defines and define about some constants, but not heavy macros with lots of replacements and stuff. And also, yes, activities can have child activities. So it's a pretty cool API, but you cannot use it in Swift unless using a little package that I made. Actually, I didn't know what to give it as a name, so I call it besogne. So yeah, it's really called besogne. But I suggest you to not use it because like it's just a proof of concept. I prefer to wait for an official Apple API or use Objective-C if you're comfortable with Objective-C. So I'm gonna do like again another demo. If I can sort it up with the mic. So. It's good. So again, it's a pretty simple tool. So it's almost the same. Just now we're calling an intensive work function. Also, I'm importing, like as I said, the besogne. I'm always laughing about the name actually, besogne, and also another package that we'll talk about. And and now you can just, as I said, create a logger instance. We will call this intensive work function that is creating a besogne. And so basically it's an activity. And then you're calling the apply API, you're doing operations like just logging, and then we're going to do a very small loop. And in this loop, we're calling a function, little work, that we just create another activity. And we can also use another API of activity, which is enter leave. So you enter, and instead of like here, giving it a closure, you can just do enter, then do lots of stuff, and at the end do a leave. So I'm logging stuff, and what I will do in this function is every time the number iteration is even, we will just generate a random number. But actually, it is leveraging an awesome package that I made, which is called Swift parity. And what it does is basically just checking if the number is even. So it's a bit of a troll, but anyway. JavaScript style. So I'm going to run it. So we're going to see some output, obviously. It's doing stuff, but here the output is not interesting. The cool thing is going back again to the terminal. I will do like a log. Actually, I have So hopefully you didn't see my password. And then it created like an archive using the log command that I talked to you about with the collect subcommand, and we're just retrieving the last 1 minute logs. And then I'm gonna open this file. So it will open the console app. So there is lots of logs, maybe private information, I hope not. And so it's a log about the system on my Mac. And in those logs about every process running on my Mac, there is my process that I just launched. It was a really quick one, just generating random number. So I just clicked here on this activities pane, and then I'm gonna filter to Cocoahead. And so it filters with my activities. And as you can see, there is the intensive work activity. And then there is this little work. So here you have the logs. Little work 1, little work 2, it is even generating a number. And every log is related. So if during this time there are lots of other logs by other process, with this tool like activities, this API, you can just filter a lot of those. 3 or 5, 5 or 5. Okay. So pretty basic. So let's get back to the presentation. So OS log, is it perfect? No. There are lots of drawbacks. The first one, as I said, as you saw it on iOS, it's per process. So you got to give it the scope, which is the current process. So if you have extensions, it's a bit cumbersome to use. It's also while the process is running, because what happens if your process just crash and you want to retrieve the logs of an earlier run, you're screwed. Unless you're doing some extra stuff like retrieving the logs and writing those two files, but it's inefficient. It's Apple only. And there are lots of rants about it online, because it really looks like a framework made by Apple engineer for Apple engineers, even though they advertise it to use it. So it's kind of cool, but as you can see, there are APIs that are not even available on Swift. So other solutions for logging, there is maybe this package that maybe you tried, which is called SwiftLog. Actually, it's a pretty cool package. First, because it's done by Apple, so it's pretty serious. Like it's maintained. So this is the URL. It's cool because it's cross-platform. So if you're doing like Swift on server and stuff, SwiftLog is a good solution. And even on iOS or macOS, you can just use SwiftLog. It's pretty easy to extend, really easy to use. Again, another solution, one that I found on GitHub by someone that I had the chance to meet at WWDC this year. It's a very cool package called Chronicle. And according to the author of this package, who is a genius, by the way, so it is fast, just like OS log. It is persistent, so unlike OS log, if your process crash, you can retrieve the logs after. And it's structured just like OS log. So this is the URL. But again, sorry, it's experimental. According to the author, don't use it because it's just a proof of concept. But again, it shows you concept that if you want to write your own solution, you can just be inspired by what it does. And actually, there are lots of stuff, but I don't know if I'm short of time. But anyway, I will just skip this slide. But if you want to see like what it does, so it's using again also macros, Swift macros, and it's pretty smart. So it does what OS log is doing almost in the same way. So you're calling the macro with pound hashtag log, then with the logger instance, and so your log. So here it's just a simple string app launch, and what it does is like I just expanded the macro, it does pretty much what OSLog is doing. So lots of stuff, not that complicated, just analyzing the message, like seeing if it has some parameter that it has to interpolate. Then it checks if the log category, the logger has to be enabled or not. And it does some calculation, like retrieving the strings from the binary, as I showed you, and retrieving metadata, like just like, okay, this is an integer, so how much space will it take, etc. So it's not that complicated. Obviously, it is a bit, but the basics behind it are not that complicated. So in conclusion, I would say like just use the right tool for your needs. May sound obvious, but depending on what you want to achieve and what your specific needs are, you may want to use OSLog or SwiftLog or other packages. You probably are using other packages, which are totally fine, but hopefully it is fast enough. And yeah, as I said, like the tools, like you have the console app, which is an awesome tool. Like I did find some bugs on macOS and resolved it, some really tricky bugs, and resolved it thanks to console. So it's like, sometimes we don't think about opening it. We just focused on the Xcode console, but this one, especially on macOS, if you're doing like stuff relying on some other components of the system, it's pretty cool. And actually, there is this other cool application, Otter, with a really cool, nice icon. And it's a tool made by an Apple engineer, and who is not anymore at Apple. And basically, it just is focusing on the activities API. So you just give it an archive, as I showed you, and it has a really cool interface to be able to trace the activities. But actually, it's not that stable. I had a few crashes with it, so we need to send to the engineer and shame him. So thanks for listening to me. If you want to see the sources, this is basically the documentation and the manual pages and some blogs.
Do we have some questions? Yes.
I have double mics. Hello, Adam. Great talk. Thank you so much for this subject. I was very curious because I know that in iOS, I think it was 16, they released a new logger. And I think one of your slides uses that actually. So I was very curious to hear what your input was on what they've built with that new logger, and whether you thought that was a good solution. I worked on an SDK and we used their new logger to get the logs on the console the way you showed it. And it was very helpful because you can, as you showed it, you can get it by subsystem and stuff like that. So it's really good. So yeah, very curious to have your input on that, and thanks, and again, great talk.
Thank you. So yeah, this logger stuff, again, as I said, it used to be only on macOS, and they improved the API on Swift, and they introduced this logger that you mentioned. So basically, like it just looks a bit more like Swifty, but it's just using another hood, the same mechanism that I showed you. And yeah, it's a pretty cool tool actually. At Proton, where I'm working at the moment, we're not using it. We're using something custom, but on some tool that I made for myself, and also a tool that I made at Proton, VPN, to debug something. I had to take a look at the logs by other processes on the Mac, such as, for example, MDNS responder, which is handling all the DNS requests by your system. Actually, we had some issues with it because the macOS is buggy, and using the console was really helpful. And just so it's basically using this API, the logging API framework. But again, as you can see, by using it, I feel the same as some developers, like feeling that it's a bit a tool made by Apple for Apple, like with this notion of retrieving lots of logs about the system. So in our case, as iOS or macOS developer, we often just care about the logs of our process and not having tons of logs in between. So yeah, it's a cool tool. Like it's by Apple, so obviously they will improve the API with new features. Like for example, the activities API, it's really nice, but it's not available in Swift yet. So what I expect is that maybe with Swift 6 and the improvements they made for performance, they will probably bring this API Swift. So yeah, it depends on your use case. Like if you have to retrieve the logs across crashes and launches, maybe it's not the right tool. So yeah, as I said on my conclusion, it depends on your needs. But yeah, it's a really cool tool.
Thank you. We have time for one last question.
Hello, I have just one question about the Activities API.
Yeah.
Usually when you have a logger that support this kind of behavior, either it's super hard to have multiple activities running at the same time and the logs going into the right activity, I would say, or either it's not supported at all. It's like just one activity and everything goes in. Does this API in OSLog manage to do that without being too hard? Like you could have like a background process doing one activity while another one from the UI doing another one, and the logs go perfectly in the correct activity, or?
Yeah. You just have to manage using the two API that I showed you. So there is a quick one which is just giving a block and then doing some operations. So it's very how to say it, how to say it in English, like c'est très localisé à cet endroit-là. But in some other use cases, like if you relying on lots of components, lots of classes with lots of APIs, then there is this other API which is the scoping API. So you just creating the scope and doing whatever you want in between. So you're not just limited by the closure, and just can retain the scope. And whenever you finish, you just leave. And everything that has been logged between those two calls, even just loggers on how to say it, child activities, will just be gathered automatically. Actually, myself, I just did this simple example, like just having one child activity, but by taking a look sometimes at the log archive that I made with my Mac and using the tool by the guy, the author tool that I showed you at the end, I see some Apple logs, and sometimes they're doing like, I don't know, maybe 5 or 6 nested activities. So it can perfectly handle this. But as I said, you feel that it's a tool made by Apple because like they are managing so much processes with lots of XPC communication and stuff. So yeah.
Okay, thanks for the answer.
Thank you, Adam.
Thank you.
Audrey. Thank you.
On lève encore, ça. Je peux, pour les notes, oui.
Comment ça fonctionne? T'es live pour le micro?
Pour les, juste les notes, pour les notes, c'est possible. Mais pour afficher les notes.
Les notes,
Ouais.
Attends.
Adam, peut-être lui sont comme ça.
La recopie d'écran, c'est pas...
T'as peur que si j'affiche, il puisse...
On peut mettre présente.
Ouais. Bon présentateur.
Comment je fais déjà? Je sais plus comment. Parce que déjà, il y a le play. Le rire. Pardon?
Ça dépend si tu as peur d'avoir les notes sur le
ça
sur
ne me
le
dérange
dessus.
pas du tout.
Attends, si tu tapes Presenter, je sais même pas où c'est.
Show Presenter Display in Window.
C'est ça?
Vas-y, clique dessus. Ah, c'est donc c'est dans le jeu. Ok.
Du coup, ouais, du coup, quand tu fais play, c'est bon?
Attends, il a pop le truc. Ah, mais c'est ça? Non.
Non, c'est pas ça.
Je vais te montrer. Du coup, vas-y, on sort. On va essayer. Là, il veut pas.
Je pense à Adam. Adam!
Attends, je vais te montrer. ton téléphone, s'il te plaît.
Ouais, pas de souci. Super. Bon, mode ne pas déranger. Comment on fait focus? Baisse. Ok. Ok. C'est bon. Oui, oui. Comment? Ouais.
And we will start with our presentation Cocoahead biometrics about maps in software. Please welcome Audrey.
Hi, everyone. Sorry. Hi, everyone. My name is Audrey. I'm a freelancer. Yeah, I've worked with Adam at Proton lately. Yeah, I skate basketball to be here. So, yeah, bear with me because I'm staying with you guys. And I did not patch my polo shirt. Okay, so if you see something, it's just the style. Okay, so today we're gonna talk about styles, maps. My first question will be, who has launched his Maps app to come here at AMO HQ? So like everyone knows how to come here. That's good. Okay. Don't we all love Swift UI maps now? What I want to talk about is just basically how Swift UI and MapKit evolved during the years. So the first thing we have is like, we have a big redesign of Swift UI in iOS 16. But the thing is that we can actually build a map using Swift UI in iOS since iOS 14. So you can basically just quickly build a map on iOS 14. With iOS 17 came some the Swift UI on MapKit with heavy redesign of the APIs, handling new result builders and so on. So iOS 17, and then on iOS 18, again, new stuff. So it's the same thing we have with Swift UI and the multiple version of Swift UI during the years. So we're gonna talk about essentials. So essentials, it's building a map. In UIKit, you had to simply, that's the basic one, just have a view controller, you initialize a map, or trying to get it in the storyboard by linking with an IB outlet, so on. Just getting the constraints, setting the delegates, so you had that MK map view delegates. You have to deal with it, like when user update a version, when user moves something, you just needed to implement something to put your logic in the map view delegate, which is was in the view, in the view controller. So you had to do it, and just setting the constraint. I'm using SnapKit here, so that it's not that big. Basically, with that you just had the card, a map, and everything was just empty map and so on. On UIKit, what you have, it's like just one line of code. And since iOS 17, you just get it with extra stuff. So we're gonna get to it later. But just with this line, you build a map in iOS 14 until iOS 17, you get that same thing. And this is on iOS 17 thanks to Result Builder, because with Result Builder, we can do a lot of things. You have those build blocks, and what happened on iOS 17 was Stitch Content Builder to create everything inside the map directly. So using that Result Builder, you can do whatever you want, and you provide the view you want to provide, like on Swift UI, like on lists, right? So what you are doing in a list, you can actually right now on iOS 17, since iOS 17, you can do it in a map. So let's start with just the camera. So you want to initialize a view. You have a position. So right now, the new thing is the map camera position. I center into the Paris region because it's just the MK coordinate region. And I just put Paris, I just put the coordinate, and everything is there. So I have the initializer where I can put the position, and I have the marker just you can see where we are, like the MO HQ. In UIKit, you have to set the camera on the map object. So you set the camera, you do kind of like the same thing. So if you have MK map camera and you have map camera position, it's kind of the same. Like, yeah, just it's animated. But here for animation, we have all SwiftUI provides. So we do not need to embed it in our initializer. The difference right now is just about the fact that instead of positioning the region in the path region, what you can also do is just like trying to get the user location and fall back to the automatic every time, so that you can have the user location being displayed, and what comes with the user location being displayed, it's another modifier in SwiftUI just to maybe make it hidden and maybe customize it. So we'll come to it later. So the second thing, it's more about the interaction mode. When you set a camera in UIKit, you have to, every time you have to write a line about a property. So property will be about scrolling enable, user interaction enable, when even sometimes you don't want to do something on the map because you have a lot of view colliding, so you have to user interaction enable equals false, and you have to zoom enable, zoom disable, scroll enable, pitch enable, and everything. So you have to write down. So like a lot of lines of code. And right now you just need to, in addition to the position, you can just put the interaction mode. So panning, zooming, scaling, whatever you want. By default, it's going to be interaction modes to all. So again, inside the initializer. And the last one it's more about the bounds. So the bounds will just trying to get the maximum, the minimum, and the center coordinate into the area you cannot move around. So just the camera bounds, I didn't set it. But basically, you can just have one more variable to initialize into your view. So on UIKit, same thing. You have to set the region, you have to set the bounds, and so on. Set the span and everything like this. So everything is a function. Everything you as a set property you have to write, which is not the case anymore because it's declarative and it's the basic of SwiftUI. Instead, in UIKit, you have all these configuration you have to set. So we talked about UI button configuration. It was the same here. You have the MK map configuration, which was kind of like same thing on the class, and you have other classes. The other classes inherited. Yeah, you have that that MK map configuration where you can actually set the style of the map you want to display. And on SwiftUI, it's basically the same. You have the standard one, you have the imagery one. This is the standard displayed. And you have the hybrid. So the imagery one will be the satellite, and the flyover would handle those. And the hybrid will handle kind of all of everything. So the imagery, and will also display the roads and the labels. So what's come next is the style, setting the style using the elevation, the emphasis, and the point of interest categories. So right now you can have including point of interest like public transport, like cars, like buildings and so on. But sometimes you can even exclude points of interest. So instead of including, you can exclude everything. and the show traffic, which is set to true or false. So map size, same thing, is the new modifier on Swift UI since iOS 17. So the transition was to get into a place where you can actually build a map since iOS 14, but also on iOS 17, the big stuff is coming. And the big stuff is enriched with iOS 18 and so on. Controls on the map. So it's not controls finger on the map, it's just the controls on the map. Controls on the map, what they are? Basically, what you see on the right, the top, the bottom, on the right, bottom right, you see there. So same thing, on the map, you just get the map, and you have like your namespace, and what you decide to do is like what I want to show to the user. I think right now the pitch toggle is not shown. You have the compass, but basically you can just positioning. You can just position your controls like you want, like in a VStack. So you have to overlay the map, put the VStack, and so on, and that's it. But what you can also do is just like having the default one, and the default one would just be another modifier where you can actually just put everything you want into the modifier without customizing it. And in that case, it will be on the default location, which is on the top right. Annotations and overlays. Annotation, we have seen one where actually I'm placing a marker on the specific location. So same thing, what you do is like placing the marker, putting a title, and giving the coordinates. If you want to remove the title, you can just have another modifier, which is annotation titles.eden, and you will just have the icon. And customizing the marker is just another view, because you have the annotation, which is taking content view. So you can actually put an image and do all these styles on the image. Same thing. Overlays is more about putting stuff on the map programmatically. So the first thing is what we had already on Swift UI. So what I'm showing right now is that what we already have on MapKit, MapKit and AppKit and UIKit on UIKit. So both of those already had it. It's just like it was kind of like boilerplate to write, and sometimes you get lost to what you're doing. So right now, you can have a map polyline, which is like MK polyline. You just have to replace map with MK, and everything is kind of sold out. So you define a walk route. So the first coordinate is the start. The last one is the ending, and you try to just write like draw a line between those. Like my drawing was kind of like not good, because the first thing, I think it's a .ai conference in Paris, and the last one was Emo HQ, where you can actually go, but it was not written like the drawing was not good, because I had to, I think I passed in through buildings and so on. So yeah, not that much. So same thing, it is the view. You have the map content builder, which is there. You have a map polyline, which are there. So you can draw your style. So strokes, you can even have dashed line and so on. So with map polyline, you can also have circle and polygon. Right now, with the tree, I can have the map. The UIKit version had more of them. They can have multi-polyline and multi-polygon. Who has already used multi-polyline and multi-polygon on MapKit? Frank. And guys from AMO, yeah, of course. Yeah, so it's not something we use so much, but yeah, they are really interesting because they make the rendering really, really interesting, really nice. The look around, it's something we had since iOS 16, I guess. I don't remember, but it was more about the fact that when you select a map, because you can also select, you have the selected position on the map, so you have all those variables already in the map view. And when you type on it, if you have like a look around view for the scene, so you have to specify a scene and you have an image you can show, it will just show that. So same thing we can do with UIKit. It is also can also be done by SwiftUI since iOS 17. So about the search, the local search basically is not changing. It is the same thing. So you have the search results, you have that same MKMap item, which is kind of independent from the map itself. So that's why it can stay. And what you have to do is just like trying to build your request, and on the bottom of the screen, you just have to iterate for every search result. You can just add a marker. So what you're doing here is inside the map. So you can, same thing, you can build your task, you can call your task and whatever, and your function who will actually do a search for that. So every time you get it, you draw a marker, you can have multiple ones, and you just get all those markers displayed in the map. So on the interaction by themselves, the interaction on the map, we have what is changing. So right now you can just call the unchange on the position, but the fact that if you start dragging the map, you will not get the context, you will not get a lot of data. You can have just manipulate it to do more stuff or heavy stuff. So the unchange is good because we will get the position, and you will just get, status on maybe if it's positioned by the user, if it's center coordinate, and so on. But what you can do, and what they are introduced also, it's map camera change, where you get the frequency, which is continuous and end, and it continuous is the starting position of the dragging interaction. And if you put end, it's just like after the dragging, you will get all the context being updated. So this is kind of like the basic to build the map, and put everything on it, and just play with it, which is kind of easy, which is good. And because it's a Swift UI view, you can have a lot of things like Apple has done with Swift UI and with views on Swift UI. So you can have the map reader, like you had the geometry reader. You gain all sorts of animations. So everything you can do with the keyframe animator, or you can have a map camera keyframe animator. So just to play with animation on the camera position of your map can be done. So what you can do on Swift UI with animation, you can just put it back here and it will just work. You will just have everything related to the keyframes, and you just play with it. So Swift concurrency is going to come. It's a big question. So all the structs are prefixed with pre-concurrency. So they are kind of prepared to support strict Swift concurrency. So this is something we can start building because a lot of Apple APIs are done with that, and we can actually have no problem using them. So we have basically all the functions, main actor pre-concurrency, or in all the structs since iOS 17 prefixed with main actor pre-concurrency. What about other maps frameworks? So what I know about the three I wanted to put was more about Google Maps, Mapbox, and OpenStreetMap. It is the same answer. So the answer is like, is Maps better than Mapbox, Map on AppKit on you or UIKit? Is it better than all those three right now? It depends sometimes on the place we are. In San Francisco, I think I use more maps. In London, I use more maps, and when I'm in Cameroon, I use more Google Maps. That's normal for me, because yeah, they don't get all the maps, all the ties, all the cards over there. So it depends on where you are. But basically, there are differences, and right now we have mission features. Because Apple is not getting out everything every time with 100% complete. So we have missing features. We're talking about markers and putting markers every time. So the big question every time is about the clustering. Who is still doing clustering on these applications? Yeah, not so many people, because they are way to, trying to avoid clustering. So when you change the map, you can recalculate, and you can try to, you define the zone where you want to have the results displayed. So you recalculate them, and you just get into a place where you don't have to do clustering, because we have a code somewhere on the internet where it is done, it is clear, and it is working. We had back in the days on Objective-C and Swift also, we had those clustering framework, those clustering libraries, they were working. Right now, we do not need that much, because we have the region changes, and we have to recalculate, and it's our iPhone are getting better and better and getting more powerful. So the clustering is not a thing this day. What can be done and what has been done on UIKit, Swift AppKit, and Swift UI is just trying to recalculate on camera change, on camera position change. You just recalculate the search result you see, if you've seen lately, and you just redraw, and everything is smoother. So no latency at all. The ties. So this is a big thing, because when you want to do heavy stuff on the map, you need your own ties. You sometimes use Mapbox, OpenStreetMap. Sometimes you build your own system around it. So it is missing. It is missing. It was missing in iOS 17. It is still missing in iOS 18. So it's not going to happen this year, at least. Geodesic polylines. Who knows about geodesic polylines? Yes, of course. Same people. So geodesic polyline, if you go into like more of a, right now we are on the how can I call it, on just the phone, right? So, but if we go into the 2-dimension thing, we can still see it on the phone. But geodesic polylines is just to have like define a lot of polylines, like the end at the beginning and the end tend to to be how can I call it, to get into, curving, and the geodesic effect actually, it's making a curve with the starting point and the end point, so that you can see that it is something related to 2D, maybe 3D, because you have like the brain is thinking about it. So so geodesic polyline are not supported at all on new Swift UI with MapKit. And same thing with multi-polyline and multi-polygon. It was the same thing on MapKit. UIKit was MK multi-polyline and MK multi-polygon. Not going to happen this year. Your own overlays. Sometimes you want to make some rendering, intensive rendering. You cannot do that right now. Same thing. So does it worth it? I think I've answered the questions. All those, intensive usage of MapKit. Sometimes we are not doing it. Like we just display a map, we just put something. We have like sometimes we do a snapshot of MapKit. Sometimes because we don't want things to interfere. But right now, I will say that, does it worth it? If you are on iOS 14, maybe you can try it to see if you need more stuff into it. If you're starting with iOS 17, I will recommend it. I will. It's like Swift Data. If you're using Swift Data, yeah, you can use MapKit. That's the only thing I can do. If you think you can use Swift data in your application, just use MapKit with SwiftUI. But MapKit is doing a lot more than what SwiftUI was doing on iOS 17. So I will recommend it because you can display whatever you want. You can have the annotation you want. You can customize your annotations. You can deal with the dragging, with the gesture, with the selected pinpoint, with the position. You can do animation, like nice animation with the camera position. You can actually make the map moving whatever you want to move it. So yeah, you can do it because you have SwiftUI behind it, and you have the power of just all those. If you're using SwiftUI, of course, if you're using UIKit in your project, do not use SwiftUI with MapKit. For me, it is obvious. But if you do, we are trying to do it because it's basically it's really fast. It's really clear to read because it's SwiftUI, and it has almost everything. The missing feature I was just talking about. A lot of people do not use it. If you're using an app, or if you're building an app specifically on maps, like in this building, yeah, do not do it, right? Because you know your stuff more. So yeah, thank you thank you for being here. I have just reference, but the reference are the same. Sorry about that, but it's mostly about everything that has been done, said, or discussed on Apple platform. Yeah.
Thank you, agree. I think the remaining mic. Do we have some questions? Yes.
About the white kit, you say that some features are missing. But if we want to use clustering with the UIKit version, shall we use? Can we integrate it with the SwiftUI map view? For example, with the map view delegate.
Yes and no. You can do cross, MapKit and UIKit, but I think it's a waste of time. Like you're trying to do something which is specific. You're trying to get a MapKit view into the UI view representables. You're talking about that?
I think so.
Yeah, maybe a MapKit, right, a UIKit MapKit view into a UI view representable. I do not suggest that. Either you choose to do the UIKit AppKit/AppKit way, either you're doing just the SwiftUI way. Do not trying to do both of them. If you think you will use ties, you will use heat map or whatever. You can use Mapbox, you can use Google Maps, you can use whatever you want, but they will be in UIKit, and it will do the work. So, yeah.
Okay.
Another question. People are hungry, maybe. Oh, yes.
It's similar to the question that I was asked, but you said don't wrap MapKit yourself in SwiftUI, use the one that was provided by the system. But you mentioned a few configurations that were not supported in SwiftUI for some reason. Like, first, do you know why they would port most of the configurations to SwiftUI and not all of them? And can you actually build the SwiftUI wrapper yourself and then use that?
When you're talking about configuration, which configuration are you talking about?
I'm talking about like MK multi-line, multi-polyline or stuff like that. Like, what prevents you from building your own SwiftUI wrappers around that?
I will not call them configuration. The configuration we put is just to trying to initialize. But in terms of just overlays, you cannot build your own overlays. So even if you're trying to do a Swift UI kit overlay wrapped into a Swift UI view, it will not work. It will not even compile. So yeah.
Okay, that's what I'm asking. They didn't provide a way to build those wrapper
No.
yourself. Okay.
Thank you. One last question, maybe. No? Okay. Thank you, Audrey. So before wrapping things up, a few things. The first one is you maybe can't see it, but I can see through the window, and I'm very surprised that there are offices that looks to be offices of BNP Paribas, with people still working at 9 p.m. and I'm very surprised to see that, but yeah, okay. Another thing, I would like to have a huge thank you to Valentin, who is here, who's been helping me for a while with the meetups, with everything technical, the live streams, the mics, the videos, and so on. And he will be out for a couple of months working on a side project that's called Baby, you know. So thank you so much, Valentin. And to help me while Valentin won't be here, we have a new Valentin, which what I had else to say. Next, Cocoahead's Paris edition, the November one, should be on Thursday, November 21st. I'm still waiting for the final approval of the company we will be at, so I will confirm that on social medias. And I think I had nothing else to say. Once again, a huge thank you for Amo, to Amo for hosting us tonight. And now it's time for beers and